starting pitcher in the American League with an ERA of 1.89. In the National League, the mean ERA in 2018 was 3.611, and the standard deviation was 0.772. In the American League, the mean ERA in 2018 was 3.744, and the standard deviation was 0.893. Which player had the better year relative to his peers?
Thank you. All right, so there we go. So, again, the question is, which player, right, okay, had a better year relative to his peers, and why? Okay, so again, as you may notice in here, Jacob deGrom from New York Mets is actually, what league is he at? National League, right? So Jacob deGrom is on the National League. Thank you. But Blake Snell is where? On the what league? American League, right? So they are on different leagues, and then you might be saying, well, how can we compare one from the other, right? Well, we can compare them based in comparison with their peers on that specific what do you call this? League. Are we good? Right? Now, how do we do this one? So we can measure this one in terms of their position from the mean, right? So how many standard deviations above if they are better, or below if they are, needs improvement, right? With respect to their peers, right? So how many standard deviations above or below are they? So which among these are we dealing with? So we are dealing with z-score. Are we good? Right? So how do we deal with z-score? So here it is. So according to our formula for z-score, we got the following, okay? Z-score is, again, it says what? How far above or below from where? From the mean, right? So how many, right? How many SDs, right? Okay. Standard deviations above or below from the what? The mean are they? Are we good? Okay. Get it? So in here, what do we have in here, right? So are we talking about population or sampling in here? Did they get a sample from the league members, or is this the statistics for everyone? Everyone. Very good, right? So it's a population, mean and standard deviation. So with that being said, let's do this one in here. What's up? How do we know it's for everyone? Well, first of all, did it mention anything about sampling? It did not, right? So with that being said, then we can already assume that this is for the entire league itself, right? But definitely or evidently in here, so talking about mean for the entire league and standard deviation, we are talking about what? The performance statistics for each of the members of the league. Are we good? Right? So with that being said, we're talking about not just a selected member or a sampling, but the entire members. Are we good? Get it? But typically, if you didn't see the word sample or random sample of, then we are assuming that it is talking about the entire population. Get it? Okay, so with that being said, let's call this one, what's this again? National League, right? So for National League, what's the mean again? And standard deviation? Okay, National League. It says here the mean is 3.611. Okay, and what's the standard deviation? 0.772, right? And who is in the National League? deGrom. Thank you. All right. Okay, and deGrom is what? ERA is 1.7, right? So deGrom, what's his ERA again? 1.7. Is this? So this is the what? This is the X value, right? That is the mu, and that is the sigma. Very good. So let's see. How far is deGrom according to or with respect to his peers, right? So we're going to use the formula. Z-score for deGrom is how much? X right? So this is population, so this one, right? X, which is 1.7, minus, what's the mu? 3.611 all over, what's this? 0.772, right? So let's see what we got from there, okay? What about the other one? About Blake-Snell. So Blake-Snell is on the American League. So I'm gonna put in here below, American League, right? So AL, American League. What's the mu and standard deviation according to American League? What did it say in there? Yes, you. Mean, 3.744. 3.744. What's the standard deviation? 0.893, right? So 0.893. Okay, now what do we have in here? Do the same for, what's his name again? Blake-Snell, right? So Blake-Snell, right? What's his ERA for Blake-Snell? Did it say 1.89? All right, put it here, 1.89. So we're gonna get the z-score for Blake-Snell as well. What is that? 1.89 minus 3.744 all over 0.893. Are we good? Okay, so let's see. Let's put in the computations in here and see how it goes. Okay, so I'm gonna X this out and put the Desmos computations in here for such. Okay, first all, for deGrom, right? So deGrom is what? 1.7 minus, what's that again? 3.611, 3.611, right? All over, what's this? 0.772, 0.772, right? So deGrom is what? 2.5, right? Almost 2.5. Standard deviations below the mean. Are we good? So again, he's 2.5 standard deviation below the mean, right? So that's way far on the left side. Are we good? Now let's see. What about Blake-Snell? It says what? 1.89 minus, what's this? 3.744 all over, what's this again? 0.893. Right? 0.893. Right? And as we may notice in here, Blake-Snell is just what? Basically just 2 standard deviations, right? If you're particular, 2.1, right? Standard deviations below the mean. Are we good? Right? So if we're gonna look into that one in here, just graphing this, okay? So we can graph it in here as well, but just to give you an idea on how it looks like, right? So this is what? deGrom, right? deGrom, like this. Supposing that this is the mean for, this is the normal distribution for deGrom. This is the mean, right? So how many standard deviations is he? 2.5 down, right? Down the line. So this is 1 standard deviation, 2 standard deviation. And this is negative 3 standard deviations, right? So basically deGrom is where? Somewhere here. Are we good? Yeah. Okay. So kind of far. However, Blake, on the other end, will be what? So if this is for the normal distribution for Blake-Snell, this is also the mean for his own league, right? He is what? Negative 2.1 standard deviations below, right? So if this is 1 standard deviation below, 2 standard deviation below, right? So he's basically somewhere here, right? Are we good? Right. So which one? What's the question again? Who is performing better? with respect to his league or his own league. So again, the rightmost the value is, the better performing you are. Right? Are we good? Right. So with that being said, what's the answer? Which one is performing better?
Good girl.
Blake Snell is performing better, right?
No.
The answer key said DeGrom.
Oh, let's see.
Yeah, the reason why is because it's based on how many runs you're getting.
Yeah, and the less runs a pitcher gets means the less like fouls that they.
Oh, okay. So what's the ERA, by the way? Okay, so
It's the earned run average, so it's for pitchers. It's like how many times they like walk a player.
so this one should be the reverse, right?
Right.
Okay, there we go. So in this case,
You want the least amount of people.
if we go back in here, the question says, let's see.
I am not a sports guy.
Baseball's weird.
So, what's the question again? It says in here, which player has a better year relative to his peers, right? So the better the year was what? What's ERA again? Earned run average, right?
So like.
You want it to be lower.
Ah, you want it to be lower. Oh, okay. So in here, you want it to be lower for the earning run. Okay, so there we go, right? So, assuming that we know that ERA means, so this one should be DeGrom. Are we good? All right. Okay. Are we good, guys? With that one being said, so again, I think we have to know a little bit of sports in here. Earn the run, what's that? Average.
Yeah.
Oh, okay.
So it says the mean of the number of runs yielded per 9 innings. So it's how many times like the pitcher had a player walk.
Right.
This
So, like,
sports
the number
analytics is
times
kind
that
of
they
like
go around the bases,
specific. Okay.
you want that to be as low as possible.
Correct.
Since
Okay.
you're talking about the pitchers.
Mm-hmm. Cool. I really don't know about the sports things, but yeah, got it? Okay. So, anyways, guys, let's now work on this one in here. Number, what's this? 15, all right? Number 15 in here, we got, okay, here it is, number 15. So we're now talking about what we call percentile ranks instead for such, all right? So let's read this one and see how we can work on this. Trey, go ahead, please.
Okay.
Explain the meaning.
Explain the meaning of the following percentiles.
All right, letter A.
Yeah. The 15th percentile of the head circumference of males 3 to 5 months of age is 41.0 centimeters.
Thank you, right? So what do we mean by that, right? So let's have this visualization in here. Can you flip this? And let's see in here where that, what's that, 15 percentile rank is, right? So when you say 15 percentile rank, as you may notice, that is the minimum, which is the 0 percentile, right? And that is the maximum 100 percentile rank, okay? So if we talk about in here, this one in green, that's 90th percentile rank, right? And this one in here is the 40th percentile rank, right? So which in here means, where do you think is the 15th percentile rank? So somewhere in here, right? So if this is first quartile, the 15th percentile rank is in here, right? Okay, we good? So that's the 15th percentile rank, and it says in here, what is this value? 41 centimeters, right? So again, this is what? 41 centimeters in terms of what's this? Head circumference, right? Which means, what does it mean? That in this case, 15% of the entire population of what? Males 3 to 5 months of age will have what? Head circumference less than 41 centimeters. Are we good? Right? Okay, so again, 15% of them will have a head circumference of less than 41 centimeters. However, what's 100 minus 15%?
85.
85%. Yeah. Okay. So that only means that if this is 15%, that means from here to here, 85% of males 3 to 5 months of age will have head circumference more than 41 centimeters. Are we good with that being said? So that means in here we can say this, okay? 15% of males, okay? What's this one? 3 to 5 months will have head circumference less than, what's that? 41 centimeters. Are we good? The other 85% will have what? Circumference more than 41 centimeters, right? So the remaining 100%. So in short, that only means that 85% of males, the same, 3 to 5 months of age, will have what? Head circumference, how much? More than 41 centimeters. Are we good, guys, with our percentile rank, right? So whatever your percentile is, values below it will be that percentile, right? But values above it will be what? 100 minus that percentile rank. Are we good? Get it, guys? Okay. Now, let's read in here. Letter C. So we have letter C in here. Let's read how can we analyze this letter C. Okay. Mason, go ahead. Anthropometry, is that?
Anthropometry involves the measurement of the human body. One goal of these measurements is to assess how body measurements can be changing over time. The following table represents the standing height of males aged 20 years or older for various age groups. Based on the percentile measurements of the different age groups, what might you conclude?
All right, so let's see in here, right? So notice the age group, right? Age group what? 20. Yeah, so class size is what? 10, right? By 10. And this goes from 20, so that means adult, right? 20 and older, okay? So that's the 10th percentile rank, 25, 50th, 75, and 90th percentile rank, right? So what will they think will be the best option for us to give, a more convincing, more confident observation or analysis based from them? What percentile rank should we deal with?
The highest one?
The highest
The
one.
90.
Very good, OB, right? That is correct. So definitely, if we're talking about a better conclusion, we want to get what? As much of the population as we can. So in short, the better or the higher your percentile is, the more it includes everyone. Are we good? Right? So if this one, when you say 90th percentile, that means you are including what? 90%, right? Of the entire population. Are we good? Right. Okay, so with that being said, what can you notice in here? Look. Okay. So look at the, what is this? The standing height of males, all right? What can you say about the standing height of males on the 90th percentile rank? What can you say?
Higher.
Huh?
They're all higher.
You're all higher, but look at as the age goes older, right? As the age goes higher, what do you notice about the standing height? When you say standing height, when you stand, what happened, right? That's your standing height. But sometimes, bless you, you get some,
Decreases.
bless you, back problems, hip problems, all these kinds of, orthopedic problems, right? Or some other problems as well. What do you notice about the standing height? It decreases, right? So as you may notice in here, the standing height decreases. Are we good? Right? So with that being said, what can you say? For 90%, okay, of the, what's this? Males, right? For 90% of males, age what? 20 up, right? 20 years and older. What do we notice? As age increases, standing height decreases. Are we good? Right? Can we see that trend in there? As you may notice, as the age group increases, what do you notice on the 90th percentile rank? 90% of the entire population of what? Males age 20 and higher and above, right? What do you notice? It's pretty consistent in here. It's going down, 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 down. Are we good? Right? So that's why it says in here, when you want to get a better, stronger conclusion, you want to get what? As much data as you can. So definitely the more percentile that you are talking about, the more it, considers every single or at least majority of the population. Are we good, guys, with that? Questions with this? What we did? Okay, letter B. What can you say about that? Okay, so let's read letter B. Caroline, let's read this one. The 90th percentile of waist circumference of females. Ooh, waist, okay.
The 90th percentile of waist circumference of females 2 years of age is 52.7 centimeters.
Okay, so what can we interpret according to that? 90th percentile, right? So that means what? 90% of females, what's this? 2 years of age will have what? Waist circumference. Lower than 52.7 or higher than 52.7?
Lower.
Lower, very good, right? So the 90% of female 2 years older will have what? Waist circumference. Is that circumference it says? Yeah, circumference. Less than, what's that? 52.7 centimeters, right? Are we good? Right? What about the 10% of them will have what? Waist circumference of how much? Greater than. Very good, right? How much is that again? 52.7 centimeters, right? So again, there's not much computing or computation for percentile. It's basically what? Interpretation, right? In terms of percentage, right? So how much percentage? Whatever the percentage means, that's the value. Whatever the value is, lower than that, right? But 100% minus that will be the values higher or more than whatever is mentioned on the observation. Are we good, guys? Get it? Questions regarding that? Okay.